So, learning target today. I can use the quotient rule to find derivatives. Pretty basic, but again, I need to give you every method possible so you are able to differentiate any type of function. So therefore, when we get to some of the related rates problems, some application problems, you know how to do derivatives of different types of functions. Okay? Quotient rule. As it's written in the book. I'm on page 121 if you want to look at it there. But quotient rule for derivatives. Okay. Again, both functions need to be differentiable. And as always with a quotient, the bottom can never equal 0. You can never be dividing by 0. That's just always kind of a given. It says it in there. I'm not going to write all that out. Okay. But if you're going to take the derivative with respect to x of a function divided by another function, the way you will do that is take the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the square of the bottom. There's a proof on 121. We're not going to go through the proof of it. But this is your quotient rule.
That's a lot.
The same thing, just the bottom, right?
Okay? Let's finish writing that down.
Okay, so you said that if f and g are both differentiable and that
G cannot equal 0 because if g was 0 or the function on the bottom was equal to 0, you couldn't do it because you can't divide by 0.
okay.
That's stated in that long definition on the top of page 121. I'm not going to write all that down for you. You're welcome to look at it. Maybe make note of it that the full definition comes on page 121 if you'd like.
Yeah, I get 5 stars.
Yeah.
That's the way to go. No problem. Okay.
For calculus. That's about it.
Okay? Everybody got that written down? Now, this one, as far as memorizing it, okay, I've heard different, for some reason my wife remembered a different one than what I did, but it's kind of stuck with her too, but this is the one that's always stuck with me.
Can you share both of them?
Okay? I don't recall hers right off the top of my head. That would require me to listen to her.
Oh,
Sending this video to her.
No.
And I quote.
Shame on you.
Oh, we're showing her this.
I will.
So,
I'll text her.
mine was low d high minus high d low over the square of what's below. Low d high minus high d low over the square of what's
Is
below.
there a song for it?
Okay, no singing.
There's a dance though.
Yes. Low d high minus high d low
This reminds me of a Magic School Bus episode.
over the square of what's below.
Hey, it rhymes.
No duh.
Good for you, Bryce. Good for you.
That's kind of the point. I feel like.
I still like
Oh wow, you actually wrote it.
for quadratic formula how I memorized that.
Yeah.
That was a fun one.
Did you get that done, Erica? I did.
And no, it's not the way it's supposed to. You do it.
Don't put it in my
Not
hair.
my-
Alright.
We were such a love there.
Okay. So, let's say we have the function y equals 5x minus 2 over x squared plus 1. Here, this would be an example of one that you really couldn't simplify and try and do it just using a power rule like we've done before. Okay, this one, you're stuck with that rational function. There's no real way to simplify that. Okay, so this one you would have to use the quotient rule if you want to do the derivative. So y prime would equal, so low d high x squared plus 1 times
5x minus 2.
Five.
Five.
Just fine.
because you're doing the derivative of the one on top. Okay?
Got it.
Low times the derivative of the high one, so the bottom times the derivative of the top. G of x, which is the bottom, times the derivative of the top. Okay, so low d high, that part's done. Minus
High, d low.
high. And then what's d low?
2x.
2x over x squared plus 1 squared.
Plus your square.
Over the square of what's below. Okay? So here's low d high minus high d low over the square of what's below. Okay? As far as simplifying this goes, in this particular case, I would probably simplify the top. Doesn't take much, a little bit of distributing, combining like terms. Okay? If they're really ugly, if they would still have lots of powers on them, like binomials raised to 5th or 6th powers, which will involve the chain rule, which we'll use next week, then you're not going to probably simplify that much. But here, this wouldn't take much to simplify. I would leave the bottom, though, as that quantity squared. Okay? No real reason to FOIL that out. You wouldn't be able to simplify anything if you do FOIL it out. If you leave it in factored form like this, there's maybe a potential that it could cancel out something on the top if you have a common factor. Okay? 5x squared plus 5, right?
Bingo.
This would be 10x squared minus 4x, but you're subtracting it. So
minus
minus 10x squared
plus.
plus 4x.
All
All over x squared plus 1 squared.
Combine your like terms there.
John, as usual, right on top of it, tell us combine our like terms.
Hi.
On my game today. You're late today.
So
Yeah,
negative
I
5x
didn't
squared
see
plus
it.
4x
Like, I
plus
don't know how.
5.
So negative 5x squared plus 4x plus 5,
That doesn't look like it's going to cancel
probably
out.
not going to be factorable. Okay? Probably not going to be factorable. 5 times 5 is 25. Think of things that multiply to 25 and then add to 4, probably not happening. So,
Especially because you're going to get an x to the 4th in the bottom. Or, never mind.
and you wouldn't have a common factor
Yeah.
anyway. That would be your derivative of this function right here.
It's a long derivative.
Okay, yep. What if I wanted to know the slope at x equals 2?
Plug in that.
Plug 2 into the derivative. Okay? Find the equation of the tangent line at x equals 2. Again, plug in 2 to find your slope. Once you know your slope, okay, use the slope and a given point to write your equation of the tangent line. Okay? Definitely putting a lot of things together here. That's going to be pretty common. Okay? Understanding derivatives are slopes of tangent lines, pretty important. Okay? So that's the quotient rule. Just got to kind of memorize the rule. Same application over and over again. So product rule, 1d2 plus 2d1. Quotient rule, low d high minus high d low over the square of what's below. Okay? Alright. Not going to spend any more time on that. You'll get some practice time on it. There's one thing that I do want to discuss a little bit more.